Hello, Sunil. Welcome to the podcast.
Hi, Andy. Thank you for inviting me to your podcast.
Well, it's great to have you with us, not least of which is because the areas that you're researching are absolutely fascinating. And I've really enjoyed getting to know your research over the last few years because you cover so many areas. But I think what's really special about your work is just how far you go back in Salford's history. I think I was reading 1982 was when you did. It's a fair way back, isn't it?
It's a long way back. Yeah, it's my 39th, it's my 40th year this year, actually.
Wow.
And 42nd if you count my undergraduate studies. Yeah, so it was kind of privileged to join Salford in 79 as an undergraduate on the Joint Honours in Science course to study computing and mathematics. And a little bit of physics as well. So in those days, you kind of jack of all trades, which was ideal for me because I had so many interests as a kind of young person.
Yeah, and it must have been, I mean, computer science back then must have been a very different world. I imagine that it was quite a sort of, well, it still is, of course, but a pioneering field. There probably weren't that many degrees that were doing this.
Absolutely. No, it was looking back, it was a time when you wrote programs by punching holes in cards and then feeding those cards into a card reader and waiting for a system in the center to come back and tell you that you missed a comma out somewhere or a full stop after half an hour. So you soon learned not to make mistakes, and you soon learned the value of trying to get your programs right in the first place.
I bet you do. And I guess going back all that way, what was your entry into sort of thinking about computer science as a career? Can you remember a point at which you thought computing is the future and you wanted to be part of that world?
Yes, I think my experiences at Salford have influenced me a lot. And Salford being a technological university was one of the reasons I chose it in the first place, rather than to go elsewhere. And I recall in the second year of my studies, because it was a joint program, you had to study computing as well as mathematics. I was fortunate to have some fantastic tutors, and both on the mathematics side and the computing side. But one of the things I noticed was that there was a gap in terms of the mathematics material was always nicely presented in terms of the rationale for it, the theory behind it, whereas the computing in those days was basically you hacked together a program, and if you were good at a particular programming language, then that was great. And in those days, it used to be Algol 60, and then Pascal, and then I don't know if people know, but Salford used to be famous for Fortran 77. We had one of the earliest Fortran 77 compilers that was sold throughout the world. And Salford was well known for that activity. So at that point, I was really keen to understand how computer science could be a science. It could be more systematic. And I recall in the second year, you had to do a dissertation in mathematics. So my dissertation is very much looking at the relationship between developing systems and the theory behind those systems. So I spent quite a bit of time looking at how you could develop computer programs that were correct, but using mathematics to make sure they were correct. And that was the kind of earlier career trajectory I had, was trying to understand how you could design systems, whether it's in the same way you design bridges, so that if you go over a bridge, it doesn't fall over. Whereas in those days, there were issues with, as there are today, with bugs in programs. How do you develop systems that are safe, whether they're safety related or safety critical systems?
And at the time, I suppose, I mean, so much has changed in computer science. It feels like computing is so present in our lives today, with social media, with artificial intelligence, with any number of industries who are increasingly dependent on the computing industry and the gains that are made there. And it's, I guess in some respects, it must feel like computer science really is at the heart of a lot of knowledge creation today.
Yes, so that's an interesting view, that it, it's obviously ubiquitous and it's everywhere, but the people driving those innovations are split into two parts, really. Those that have the capability, the resources to develop those systems, and then the user groups that tend to use those, pay for those services, and sometimes are lulled into false sense of security about how those systems and the data that's provided is used. It really is a huge gap between what I would call the practitioners and the users. And there's the other side, which has always influenced me, is to close the gap between the theory and application of AI. So I've really been working hard on trying to close the gap between the theory of AI and the application of it, and also seeing how the practice could be improved and could influence the theory. So both sides of the theory practice kind of relationship is fascinating.
And I think it's the sort of subject, particularly with artificial intelligence, where people have an idea of what it involves and what it may be doing to society and what impact it's having. But when you look back on the history of computer science, was there a period where sort of artificial intelligence suddenly sort of became a really important area or methodology or way of thinking about designing computers? Or has it always sort of been present in the history of computer science, would you say?
It's always been there since the days of Turing, of course. And
yeah,
of course, there have been different waves of optimism. They were probably in the third wave. I recall the first wave was mainly around neural networks, and that wave was squashed by observation that simple neurons didn't work for simple problems. A famous paper by Papat and Minsky condemned AI to the backwaters for many years in the 70s. And then there was a second wave where really I got really interested in what's known as the expert systems era. And that was driven by something called the fifth generation program that the Japanese created. And they had ambitions of creating intelligent machines based on logic. And from that, there was a programming language called Prolog, standing for Programming and Logic, which we introduced at Salford in the 80s as a core part of the curriculum. It's still a core to this day. But anyway, the Japanese ambitions meant that the UK, the States, and Europe followed with similar ambitions. In the UK, there was something called the ALVI project. And the ALVI project tried to do something slightly different in terms of the expert systems era. At Salford, we engaged in that drive, and we had various systems. I recall at the time Peter Brandon had joined Salford. Peter, of course, famous for driving research at Salford in the 80s and 90s, getting built environment to 5-star rating. And so Peter, I think, initiated something called ELSI, which was an expert system for the construction sector. I'm just trying to remember the kind of people involved. Andrew Basden was one of the RAs or research fellows on that project, and Graham Cooper, who was some of colleagues will know, was also on that project. I myself was involved in something called Dust Expert, which was for the health and safety executives. So just to give you a flavor of Salford and of the kind of work we did in those days, we used to have something called Salford University Business Services Limited. And that was our commercial arm. It was one of the first commercial arms that we had. And the health and safety executive were interested in reducing the number of explosions in the chemical process industry. They're called dust explosions, but they include things like flour mills, where you can get a little spark in the vessels, and that kind of results in an explosion. Kind of larger scale things like exothermic reactions. So some people may have heard of the incident in Bhopal in India, where there was an exothermic reaction, I think, in making batteries, and lots of people died. And there are similar incidents that happened with small explosions. So they were interested in developing an advisory system that would reduce the number of explosions that happened. And they came to Salford through this company called Subsil. And Subsil approached me and said, can we develop an expert system that would help them? Of course, being a young researcher, I said, of course I can. And we set off trying to do this. And they engaged 30 companies from something called the British Materials Handling Board as part of the project partners to fund it as a feasibility study, which lasted about a year. And in that year, we developed a prototype. And to our astonishment, the British Materials Handling Board said, that's great. It was meant to be internal, but can we not do this on a bigger scale and start releasing it to everybody and commercialize it? At which point I got very nervous, because these were obviously safety incidents. Something goes wrong, somebody dies, kind of system. Yeah. And they said, don't worry, we can do this. We'll give you some money for 2 years, and you can develop another better prototype than the one you've got. And we did that, and at the end of it, they put it through they wanted to release it, at which point I got very nervous indeed. Luckily for us, the Health and Safety Executive Legal Department said, no way, you can't release this. This is developed by a university. There's no quality assurance around it. If something goes wrong, we've had it. So they then appointed Lloyd's Register to develop a specification. And from that, they appointed a company called Adelard, which by pure chance, by pure luck, Adelard's developers included a certain person who was my internal examiner for my PhD on the theoretical work I did at Manchester for my PhD. So all of a sudden, the system we were developing was going to be developed using some of the material on the theoretical mathematics or the logic that was used. And that system went live, and it was marketed by the Institute of Chemical Engineers. So again, kind of highlighting that Salford as being one of these institutions that wanted to develop systems that were going to be used in practice, and then the way theory and practice can come together, which is, for me, was very exciting to do.
Which I'm sure remains a thread in everything that you do still. But I want to just reflect again a bit on that period of development, because of course, I mean, I was at university when the internet or the World Wide Web really became a big thing. I remember the sort of transition into having email, and I suppose it has become such a focal point of attention publicly, as you mentioned earlier, partly around user awareness of what is happening within platforms, people understanding issues about their privacy. And yet, of course, with Sir Tim Berners-Lee's famous quote, "This is for everyone," the computer revolution was really a period whereby we would sort of take greater ownership of the means of production, of control of our lives. And yet we find ourselves increasingly sort of subject to technology. How do you sort of see things playing out technologically in terms of computer science? Are you sort of optimistic about its capacity to make positive change for the future, or are you like Elon Musk or Stephen Hawking's anxious about AI and the future?
Yeah, I think throughout my career, I've kind of seen both sides where I've been fortunate enough to develop what I would call small-scale systems that then take off. So they can be quite simple systems, and the simple systems then get used in practice. So an example would be the work we did with Carl Dayton many years ago. And we had a knowledge transfer partnership in the early, I think it was 2011, where we developed a system for subprime lending, so assessing risk when lending to people who can't afford loans or not given loans by banks. So that's an example where if you'd applied the kind of concerns that you've got today, you probably wouldn't have started doing it at Salford. You would have kind of been scared off trying to assess people in those positions. And that's why banks avoid using lending to them in the first place. But then you end up with people who are kind of excluded financially, and then end up in a worse position than they should do if there was support. So we embarked on it. We kind of used data to learn whether people are likely to return the loans that were given to them. And to our surprise, we were able to do this because banks at that time weren't able to do it. So that's an example that, you think about the difference it made to East Lancs Moneyline, that combination of the social sciences coming together with the technologists, the computer scientists, to develop a system that aids people who were financially excluded before. They grew from something like 2 outlets, one in Burnley and Blackburn, to 14 outlets. And I recall going to the new office at Salford city centre and sitting there and watching people coming for loans, really being overwhelmed by the support they received, the difference it made. So I see similar kind of things in the use of AI, where you get innovation happening that wasn't there previously, but then you've got the other side that you've got to take care. So there are lots of examples, of course. You kind of know with the recent events that with the use of surveillance cameras and face recognition technology, the researchers at Microsoft, I think one of them end up kind of saying how horrible it is that these systems discriminate. People have done studies. National Institute of Science and Standards and Technology, for example, have looked at over 280 face recognition systems that are being used. I personally didn't know that were that many, but over 280 different face recognition systems being used, and the level of discrimination varies from around 10 to 100, over 100% false positive rates, depending on the color of your skin, which is obviously really bad. But equally, if you don't have that technology, you won't be able to use it for diagnosing cancer, diagnosing liver disorders, and so on. So you've got to somehow balance. You've got to somehow balance and take out the negatives and put constraints in to take out the negatives. Again, coming back to the dust expert example, one of the key challenges we face there were similar. The challenges that we face now are similar there, that if something goes wrong, people are going to die, explosions are going to happen. So how do you develop these systems in a way that it reduces those chances? Well, what you do is you put in high integrity software quality measures in place. So in our case, one of the challenges was that I wasn't an expert on explosions or the chemical reactions that take place. So how do you get that knowledge into a system from those experts? So instead of doing that directly in terms of code, we developed a toolkit that enabled the experts to sit in front of a computer and encode that knowledge directly without any kind of translation taking place. And they were able to do that. And that was the turning point in terms of being able to develop that system and make it reliable. The level of integrity reach was kind of, probability of failure being less than 0.001. So kind of really high integrity kind of levels, which was only achieved by thinking about the trade-off between what could go wrong and the benefits that accrue if you get it right. And I think that's what we need to do with AI at the moment. Another example at the moment is that with autonomous vehicles, one of the challenges is make sure that people can't hijack the autopilots on these systems or kind of intervene in a malicious way. So one example would be if you could shine certain patterns on a stop sign. Instead of being a stop sign, it's recognized as a 30 sign. So researchers are able to do that. So you can imagine the chaos it might cause if somebody wanted to create that chaos, either by hijacking the autopilot or by manipulating signs that are on the roads. So how do you, the question is, how do you now overcome those challenges? Well, you've got to design your AI in a way that kind of predicts that those interventions might happen, and then putting in constraints that stop those happening.
It's really interesting because hearing you talk, it's very clear that the involvement of experts in this case, but citizens more widely in the progress around computer science, and particularly AI, is really important. And I want to talk a little bit about the Greater Manchester AI Foundry, because that's certainly a central sort of methodology for developing solutions for companies. Tell us a bit about that project and where it is at the moment.
Yeah, so that's really good of you to ask about the AI Foundry, because that's really my passion at the moment. The reason it's my passion is, first of all, obviously, it comes back to closing the gap between theory and practice, because it's about helping companies. The key thing for me is the haves and the have-nots. So again, the likes of Google, Facebook, Microsoft, and some larger universities have the resources to develop these systems and develop the innovation around it. SMEs don't have that opportunity or that level of resource. So the predictions are that the UK, for example, is going to benefit from AI in terms of growth by 630 billion by 2030. That's pre-pandemic figures. That was the projections that were there, and obviously worldwide it's much into trillions worldwide. But SMEs are going to be left behind. Greater Manchester SMEs in particular might get left behind unless there is the support. So the AI Foundry is about giving that support, to help them innovate, to help them create new products and services, and then to use those in practice and develop their businesses, and hopefully create growth for the region and increase employment. So that's what we're trying to do. We've got it's a project that's led by Manchester Metropolitan University. It includes Salford and includes Lancaster and includes Manchester, each with their own expertise. So we started in a couple of years ago now, almost a couple of years ago. By end of October would be 2 years. So the idea is to recruit companies, SMEs, in Greater Manchester. First of all, get them to think about the innovation. What is it they want to try out? What sort of ideas? And then to introduce them to some of the AI technologies that are available. And that's in phase 1. So we have workshops to do that, 7 workshops, of which you kindly contribute to one, Andy. Those workshops really include our business schools. That's Richard Drone, Ambereen Khan, and Solmaz Rohani, who provide the guidance on innovation and business. So one of the key things there is that SMEs and in general many companies, if they're driven too much by the technology, don't think about the kind of issues we were talking about earlier, the ethical issues. They don't think about whether there is a gap in the market and whether they can exploit the market. So our business school colleagues have been great at giving them that background, and then to think about how they go about innovation and the difference it would make commercially to them, and creating a business plan. And then the staff in science, engineering and environment, in computer science in particular, come in and talk about the AI technology, and then lead them to understand the options available. And that's phase 1. At the moment, we've had 25 companies that have been through phase 1, and they've all kind of enjoyed the talks. And then in phase 2, we have some data scientists and AI specialists who will provide them support for developing their products and services. The great thing about the universities is it allows us to put forward our top experts. So Andy, you give a talk on ethics. We have people like Terence Fernando talks about the use of digital in transforming disaster recovery methods. We have Chris Hughes talks about his work with the BBC on captioning, and then you've got people like Mo Sari, who's our lead for the MSc in data science, talks about the course and the support the students could offer. So it's a wonderful opportunity to display the expertise we have in the university, bring forward our students, engage them in projects, and then hopefully in the future increase the number of knowledge transfer partnerships. So we benefit significantly, but the companies hopefully will benefit significantly, and then the region will benefit going forward.
I mean, certainly hearing you speak, Sunil, it's very clear that values drives a lot of what you do as a researcher, but also the research that Salford does in working with both communities, but also in the industry sector. And whether it's trying to minimize the chance of explosions or whether it's trying to empower companies to take more ownership of the innovation around them, these are really about enabling people to take better control of their sector, but also to make sure that people feel part of the process. Because I think in some respects the recent history of computer science, and particularly those big companies that you mentioned, is that they are so powerful, and it's so perhaps easy for companies to simply rely on their platform to develop their own service, that it's really a bigger challenge to then reclaim that space.
Yeah, no, I'm really influenced by my early days at Salford. I recall I was recruited as soon as I graduated. I was recruited as an RA to support develop of a contouring package for Lowestoft Research Labs to look at the number of plankton in the sea and its effect on the environment. So that was an interesting project. But as an aside to that, by chance, the colleague who recruited me, a guy called Leslie Fletcher, who later became the head of mathematics, took me to Booth Hall Children's Hospital, and they had a problem with dietitians sitting there just entering numbers in from a book called by McCants and Widdowson's that looked at the nutrition content of each food item. And she would spend days and days just entering this information, getting one of the numbers wrong. So we're going back kind of to the pre-80s, I guess, or just mid-80s, I guess. And we took a look at this and said, "What are you doing? Why are you spending so much time?" So we went back and we contacted Leslie Fletcher, contacted the book authors, and they sent us some paper tape, and lo and behold, we were able within a month to give them a kind of basic system that would do this for them. And the great thing was that from that simple kind of wish to help them and support them, we suddenly had around 25 hospitals wanting to use the system, had a workshop around it. And before we knew it, they took hold of it. It was like wildfire. And kind of later on, Leslie Fletcher and a lady called Sally Basson were able to get a European grant on the back of that, how to make sure that children who have some issues with diets can optimize their diets and remain healthy. And then from the back of that, there was a company that was launched, and that company is still alive. And a couple of years ago, I was at Manchester Met at a seminar, and somebody approached me and says, that system is still running and that company is still alive. But I hadn't realized that there were thousands of users nowadays of that system that was developed. It wasn't, I should emphasize, the version that I was involved in developing got upgraded many, many times over and in different languages. But today it's in the thousands of hospitals. It's exactly that point you make. It wasn't kind of led completely by the university. It was the community it was a seed that was planted, and that seed just took off with the community engaging and developing by seeing its value to them.
And it's so fascinating and inspiring to hear about the impact that the research can make, and especially to hear just how collaborative it is to work with social scientists, people in the business school. I think in some respects that's Salford does very well at making space for collaborative research, and it's great to hear those stories across your career. Unfortunately, we are out of time, but we've covered such a great breadth of your work, and I really look forward to seeing the outputs from the Greater Manchester AI Foundry project. So thank you, Sunil, for joining me, and look forward to seeing you again soon.
Thank you, Andy. Thank you for inviting me. It's been a real pleasure to share some of my thoughts.
Take care, Sunil. Bye-bye.
Take care, everyone. Bye.